Hi, this is a short summary of a poster I will be presenting at Strings 2025 titled The Casimir and Completeness Relation for 2d-CFTs. This is based on some works done in collaboration with Jean-François Fortin and Witold Skiba in September 2024. Now, the protagonist of the poster is going to be the Virasoro algebra, which is a well-known infinite-dimensional algebra with the commutation relations presented here in the slide, which is important for any two-dimensional conformal field theory, since it represents the local conformal algebra, and it's also relevant for string theory, in particular for the worldsheet approach of string theory. But despite its relevance, and despite the fact that for decades it had been studied, there are still new aspects that are yet to be understood. And in the poster, we will focus in particular on two for which we could derive new expressions. And in particular, the two things are the resolution of the identity, also known as the completeness relation, so the way to decompose the identity operator, in particularly on Verma modules. And secondly, an expression for a Casimir operator, or rather a generalized Casimir operator for the case of Virasoro, which is going to be an operator that commutes with all of the generators of the Virasoro algebra, in addition to the central charge. Okay, for the first main result, it's important to discuss the Shapovalov form, which is also known as the Gram matrix for the set of states. And in the case of Virasoro, it can be thought of as that object whose determinant gives the Katz determinant, the one presented in the slide. This is, in particular, the object that dictates when singular vectors are present in a certain representation of the Virasoro algebra. This is relevant because the resolution of the identity can be written in terms of the inverse of this Shapovalov form, and this is already well known. It can be done in the way presented in the middle of the slide, in terms of this inverse Shapovalov form contracted with products of the generators. So these new indices represents partitions of integers, actually. So it represents more generators all at once, a product of generators. Our main result, though, is a new expression for the inverse Shapovalov form, which we could derive using an inductive procedure. And in particular, we got the expression written in the bottom of the slide, which is expressed in terms of the Virasoro singular vectors and a set of coefficients Q, which we could derive explicitly. So the inverse Shapovalov form is completely determined analytically for any level in terms of singular vectors. Our second main result is on the Virasoro-Casimir operator, which, as I mentioned, is something that commutes with all of the generators of the Virasoro algebra. And for this case, it's going to be an infinite order operator, so that's why generalized. It's an object whose eigenfunctions are the conformal blocks, so it has potential applications in that direction. And furthermore, it has been already considered as a potential candidate for a gauge covariant action in string field theory. Our main result in this direction is that we actually derived an expression for this Casimir operator in terms of the R inverse Shapovalov form. We used some recurrence relation, which we could solve explicitly, to find the expression written at the bottom of the slide, where we just kept the dependence on the inverse Shapovalov form, but as I already mentioned, we derived one in terms of singular vectors, so also the Casimir operator is determined. Finally, as a bonus, we could use our completeness relation to find a new expression of Virasoro conformal blocks in terms of singular vectors. So for more detail, I invite you to come talk to me at the poster session. Thank you very much.